Hello and welcome to Math 2, Unit 6. This is lesson 6.3, Distances and Circles. Today we are going to be deriving an equation for a circle in the coordinate plane. And this video is going to be focusing on our warm-up. Andre says, I know that I can find the distance between 2 points in the plane by drawing in a right triangle and using the Pythagorean theorem. But I'm not sure how to find the lengths of the legs of the triangle when I can't just count the squares on the graph. So if you remember earlier last week, we found the distance between 2 points, right, using the Pythagorean theorem by creating a right triangle. However, we don't really have a grid here, so we can't count squares. So we have to think about what information are we given and what do we need to find in order to find these distances below. So let's first start off with what we're given. Right, so we're given point P with the x-coordinate of 8 and 12, and then point Q with an x-coordinate of 53 and then a y-coordinate of 22. And it will be helpful to find the x and y coordinates for point N. So I'm going to draw like a dashed line here. Okay, so we know that the x-coordinate of point Q is 53. So we actually know that this value is 53 over here. And then we know that if I extend this line, right, we know that this total distance here is 12. So I'm going to label this part over here as 12. So we've got part of it at x equals 53, and then we've got the y value at 12. So I'm going to go ahead and write this down as our coordinate pair for n, which is at 53, 12. Okay, so now we need to start to find the distance of Pn, Qn, and Pq. So let's take a look at Pn, right? So we've got this line segment P and N over here. They both have the same y value at 12. So we're trying to find this horizontal distance over here, and we can actually subtract the x coordinates. So what that's going to look like, and I'm going to write that in green here, we've got the 53 minus the 8. And that is what's going to give us this distance over here. So we've got the 53 minus 8. And then on this side for Qn, we know that the x-coordinate is not changing here. It's still 53 for n and q, but that vertical distance is what is changing. So we start at 12, and then we're going up to 22. So think about, how would I find this distance over here? And pause the video to try it out. So we can take the y-coordinates, 22 minus 12, and that's going to give us this distance over here. So what I'm going to do is actually draw this triangle out below so that you all can see clearly. So we have this triangle here. We've got Q, P, and N. So we know that this distance we found is 53 minus 8. So 53 minus 8 is going to give us 45. And then we know that the distance between Q and N is going to be 22 minus 12. And so we see that 22 minus 12 is going to give us 10. Okay, so we actually have already found the answers to the first two. So I'm just going to put them here, 45 and then 10. All right, so our last question over here is to find the distance of PQ, right? And if you remember, when we have a right triangle, we call PQ our hypotenuse, right? So this is our, I'm going to write this down as our hypotenuse. And our question here mentioned the Pythagorean theorem, right? So I'm just going to write that down here for our reference. So we've got a squared plus b squared equals c squared. So when we look at this right triangle, right, we don't know what our hypotenuse is, but we know that it is always going to be our c value. Our 10 can be our a value, and then our 45 is our b value. So now we can actually go ahead and just plug in these values into the Pythagorean theorem and then solve for c. So we know our a is 10, so I'm going to put 10 squared plus, we know our b value is 45, and we are trying to solve for our c. So 10 squared, right, that's 10 times 10, so I know that's going to be 100. 45 squared, you can type that into your calculator. That is 45 times 45. It's going to be 2025, so 2025 equals our c squared. And then if we add up this side, 100 plus 2025, we end up getting 2125 equals our c squared. Now we can just take the square root of both sides, right? And when we take the square root of c squared, the radical and the exponent cancel out, and we're left with c equals, and then if you type in the square root of 2125 in your calculator, you'll get approximately 46.1. So this is our hypotenuse, right? And that is actually the distance between P and Q. So I'm going to go ahead and write that over here. All right, I will see you in the next video for activity 1.